What's a transient term mean? As the independent variable goes to infinity. Yes, cool. Right, so like each of the negative x is an obvious one, x to the negative 2, if that ends up in the answer there. Yeah, exactly. So the idea of a transient term right now is pretty simple. Like I said before, it's going to become a little more prevalent later this semester. So I might not make a big deal out of that, to be honest. I mean, you could write, oh, screw that. I mean, you see how the x cubed, so you could write y equals x times the cube root of c2 minus 3 natural log of x. Is that better? No. But I mean, it's something you could do. That's the cube root there. Okay. Enough of that problem. Please let homogeneous not be too evil, right? You could even get through most of the problems without worrying about ever doing x equals vy. But if you do y equals ux and it's looking pretty gross, you should go back and just try x equals vy. And see if you forgot the rule of thumb about if the m1 is easier, you should use x equals vy. If the n is easier, you should use y equals ux. If they're of the same difficulty, then who cares? Right. Are you guys with me here? Are you guys with me at all? You lost me at this is the syllabus. Oh, shit. Yes.
Oh, yeah.
Yeah.
I remember seeing just like YouTube videos where you plug UX into Y without making, without solving for U. Is that a thing?
Oh, yeah, the books method is in there, and they don't write it in terms of explicit ratios. They have the whole check the t to the n power to check if it's in homogeneous form, and then you can... So they avoid creating this ratio entirely. So if you want to do it that way, the book has got it for you. Personally, I just don't like that way, but if it makes more sense to you, great. I love it. Do it. I love it. This just makes more sense to me. I just like to be able to see things better, right? These are ratios. That's why it makes sense that I can. Like the whole thing, hopefully the point made sense. I had somebody that I was observing, and they taught y equals ux, and they didn't say anything about it, and the students are like, well, how do you know that? I think this is what I was saying. How do you know that y is some function of x times that? How do you know that's true? And she's like, I'm not sure, but I don't blame her. It's been a long time for her since she taught it last, but this is part of what we have to do as teachers, to go back and say, do I even remember why the shit we did that? I mean, that's, right? I want it to make sense. I want every step in the process to make logical sense as to why we would even try to do that, right? So no, if you like the textbook method better, beautiful. It exists, it's there. If you come up with your own method, as long as you show me the steps, I might even steal it from you if I like it. Some of the methods I teach are things I've stolen from my students. I love it. There's no copyright, too bad. So if it makes more sense to me and I like it, I'm going to use it.
So we would get the same answer. We just for all the y's, plug in ux. And then just went from there.
Yeah, exactly. Yeah. Plug in ux and the y's. You have to figure out what dy dx is, of course, same thing. Yeah. Totally would work the same way. It's just for me, it makes more sense to see this. If you don't care about this and you try the book method and you're like, that actually makes more sense to me, please do it that way, please. You'll get the same freaking answer, right? Math didn't give a shit which way you do it. It's the same substitution. Okay. Anything else you guys want to cover? Oh, I really just gave that to you in the homework so you could see that they existed. I mean, they're one attempt before the days of computers for the poor people that actually had to map this stuff out by hand. They came up with this idea of, it almost feels like the idea of level curves, like I was telling you, so in a way. And when you first do it, it's freaky. Hopefully it makes sense now. You know, if I put a problem on there, it's not going to be one you actually have to plot out. It might be a conceptual question, but no, I'm not going to have a plot this thing using isoclines out, yeah, or null clines for that matter.
What are you talking about?
The isocline problem, where you figure out the line along which all the linear elements have the same. It doesn't even have to be a line. There was another one that was circles, and they were all the same slope. So it's not the same thing anywhere near, but it's like level curves where it's you don't go up or down if you travel along a level curve, right? So isocline is if you just travel along this path, the slope of all the linear elements will be the same along that path. It makes it quicker to kind of plot out a direction field. Okay, I'm going to have to take my word for that, maybe. Hopefully you did it.
1.3 going to be on the...
Oh, if it is, it's going to be where I give you the formula, and then you just have to use it. To be honest, I mean, I might give you something like you see in 3.1 as a bonus question. I mean, 3.1, I think I said this last time, right? 3.1 is bonus. Did I say that? Well, all right. 3.1 is bonus.
With 1.3 extra credit too?
No, 1.3 is not extra, sorry. 1.3 you gotta do. I want you to know these things exist. I want you to see a few examples of where differential equations come from, and just some basic of how to use it. I could give you a problem that you don't have to do any 1.3 stuff too. I'll say this equation comes from LRC circuit, and the equation looks like this. Solve it, right? And then you just solve it using one of your methods. Does that make sense? Okay.
Using some type of method we've already...
Yeah, exactly. But I'll set the equation up for you. That could be like the backstory of where the equation came from, and then you solve it using the right method, right? That's really what 3.1 is, but 3.1 is you set it up yourself, and then you pick the right method to use to solve it, which is, reality, right? Okay, we're not quite in reality yet. I don't know if I just tripped anybody out. Did we say we're not in reality? What time is it? Oh wow, that's pretty good. You guys are okay? Any other questions about anything? I don't mind leaving a few minutes early. It's fine with me. David never showed. Okay. Oh, real quick, Deneen, Ben, Quinn, Lee, Allie, Sewer, Allie,
Yeah.
Warren, Wow. So you guys that just got your quiz back, you can still make corrections to it due Wednesday. So don't forget, if you haven't done the quiz 1, quiz 2 corrections, they're due Wednesday. If you want full points back, as many as you can, get back. Cool. You have my office hours. Come by. That's what I'm there for. All right.